This recording is to help you with lesson 2.06, rational functions and asymptotes. Alright, the first thing we're going to start with is finding the domain of the function and then identifying any horizontal and vertical asymptotes. Alright, to start, let's find the domain. That's where your denominator cannot equal 0. So I would have 2 minus x cannot equal 0. Add x to both sides, x cannot equal 2. So it's all real numbers except x equaling 2. Now it's kind of nice because the vertical asymptote is the same thing. It's x equaling 2. Your horizontal asymptote can be used or can be found by using the degrees or comparing your degrees of the numerator and denominator. Now because they both have a degree of 1 in the numerator and denominator, I take the coefficients in front of the x's there. So 1 over negative 1 means I have a horizontal asymptote at y equaling negative 1. And these rules are found in the online lesson, and it would be wise to write those down in your notes. All right, next we are going to determine the domain of f and g. Remember, let's start with f. Your domain is all real numbers except x cannot equal 2. Because that would, or negative 2, sorry. Because that would result in your denominator being 0. G doesn't have any restrictions, so we're going to just say the domain is all reals. Now, B, finding the vertical asymptotes, is very easy if we know the domain. Because we would just say, well, it has the vertical asymptote of x equaling 2 for f. But then we have to be careful. Does it really have a vertical asymptote there? Because we have to look. Can I factor the numerator and cancel something out? So we have to be actually careful when we're looking for those vertical asymptotes. And yes, we can factor that numerator. It factors to x plus 2, x minus 2. All over x plus 2. Now, can you cancel anything out? You're thinking, yeah, you can cancel the x plus 2 out. So now that the denominator is gone, is there really a vertical asymptote? The answer there is no. There's no vertical asymptote anymore because you could cancel that x plus 2. However, just because there isn't a vertical asymptote doesn't mean that the graph is solid. We have what we call a hole at that point. So there's not a vertical asymptote, but we do still have a hole. And when we fill in our tables, that's why we get undefined right there when we plug negative 2 into f of x. So this is where the hole happens. All right. So we answered A, we answered B, and that there's no vertical asymptotes in either one. We filled in the table for C. And then D is where do they differ? They only differ where that hole is present in F. All right, the next one. If you see a problem like this on your homework, it would be wise to draw a graph. So the first thing I did was drew the graph of 4 minus 1 over x on my graphing calculator. And I came up with something that looked like this. Right, what it's asking us is what number is my graph approaching from the top and the bottom? So what number is that? Or what is your horizontal asymptote? And your horizontal asymptote here is 4. So that's the first part. As x goes to positive or negative infinity, my graph in both cases gets closer and closer to 4. It never touches it, but it gets close to it in both directions. Now let's look at it as it goes to infinity. Yes, it's getting closer to 4. However, your graph is actually under 4. It's less than it, right? So if my vertical asymptote were this red line, and that red line is the number 4, the graph as it goes x goes to infinity is underneath that red line. It's less than it. However, the graph as x goes to negative infinity is above the red line. So it's greater than 4. And that's what we have to state in part C. So as x goes to negative infinity, f of x goes to 4, but it's larger than it. It's above that asymptote. All right, the next one is find the zeros, if any. Well, there's a couple ways you can actually do it. You can factor it and just look at the numerator, or it helps, we can just set it equal to 0 and solve for x. So in order to solve for x, we have to multiply both sides by x plus 1. Well, that just gives you 0 equals x squared minus 4. We factor that. We get x minus 2, x plus 2. The two zeros are x equals 2 and negative 2. So a couple ways you can go about it. I actually prefer just setting it equal to 0 and solving. But that's up to you. All right, the last one, we have this problem here, the cost of millions of dollars for removing P% of the industrial and municipal pollutants discharged into a river is given by that function there, that cost function. So find the cost of removing 10%, 40%, and 75%. Well, all we have to do is just plug in 10, 40, and 75 for P and see what we get. And so if we do that on the next slide, we would get 28.33, and everything is in millions of dollars. You get 170 and 765. So that is just doing your basic math there. D asks, according to this model, would it be possible to remove 100% of the pollutants? Now you can go and say no, because every time I plug in a bigger percentage, the value increases dramatically. Another way to tell is you are given a restriction here on P. If we notice, is there an equal bar right there by 100? P is less than or equal to 100. No. It's just P is less than 100. Because you have that restriction of P is less than 100, it can never equal 100%, meaning you can never remove 100% of the pollutants. That restriction right there tells you so.